Welcome everyone, we are Education Lift, and today we're going to go over the commutative property of addition. Now let's go over two stories of adding different collections of blocks together. So in our first story, let's say we start with 2 blocks, and then we decide to add 3 blocks. So in our file collection, the way we get our final answer is we count the amount of blocks we have in total. So we have 1, 2, 3, 4, 5. So this is 2 blocks plus 3 blocks gives us a total of 5 blocks. And we could write this as an addition problem as 2 plus 3 equals 5. Now, in the second story, or in story 2, let's say instead we start with 3 blocks and then we add 2 blocks. So notice we switch the places of these collections of blocks. Well, we still get the same amount of blocks in the end. And we could do that by counting the amount of blocks we have. So we have 1, 2, 3, 4, 5. And look at that. 3 blocks plus 2 blocks equals 5 blocks. And we can write that as an addition problem as 3 plus 2 equals 5. So in story 1, we start with 2 blocks and then we add 3 blocks. And in story 2, we start with 3 blocks and we add 2 blocks. So whether we start with 2 blocks and then add 3, or we start with 3 blocks and then add 2 blocks, we still got our final answer of 5 blocks in the end. And we could write this as an addition problem as 2 plus 3 equals 3 plus 2. But this is what's very interesting. In essence, we could switch the places of the numbers, and we still get the same final answer of 5. And this idea of switching the places of the numbers and adding them and still getting the same answer in the end is what we call the commutative property of addition. So, we could say the commutative property of addition the following way. If we add any 2 numbers, the numbers can switch places, and we still get the same answer when we add them. And so in our example, we saw that 2 blocks plus 3 blocks equals 3 blocks plus 2 blocks, because in the first one we had 5 blocks in the end, and on the second one we also had 5 blocks in the end. And the way we write this is 2 plus 3 equals 3 plus 2. Now, a couple important points. The first one is for the commutative property of addition. It has to work for any 2 numbers. So in our example, we had the 2 and the 3, and we were able to switch the places of the 2 and 3, and we still got the same total at the end. This should work for any 2 numbers we have. So 4 plus 5 should equal 5 plus 4 as an example. And when we add them, after we switch the numbers, the places of the numbers, we should get the same answer. So these are very important points for the commutative property, that it has to work for any 2 numbers, and after we switch the places of the numbers, we still get the same answer afterwards. Alright, so we could also write this with its answer. So we could write this as 2 plus 3 equals 3 plus 2 equals 5. So these are different ways we could write down the commutative property of addition. Let's look at story 1 and 2 again. And so here we got 2 plus 3 equals 3 plus 2. So we talked about how we could switch the places of the numbers, and when we add them, we still get the same answer of 5. But another way we can think about this is we could say we change the order of the numbers 2 and 3. So let's talk about what we mean by changing the order. So let's take our 2 plus 3 equals 3 plus 2. So here we have 2 plus 3. We'll call this order 1. We first started with 2, and then we added 3. So first was 2, and the second was 3. Now, in 3 plus 2, which we'll call order 2, we started with 3, and then we added 2. So the 3 was first, and the 2 was second. And so, in some sense, we did change the order, which number came first and which number came second. And so we could also say the commutative property of addition in the following way. If we add any two numbers, we can change the order we add the numbers, and we still get the same answer. So this is the same idea as when we talk about switching the places of the numbers. The numbers appear in a different order. And so this is probably the most common way you'll hear the commutative property of addition being said. All right, so we talked about the commutative property of addition this video. In the next videos, we're going to talk about more examples where the commutative property of addition works. And then we'll also talk about why is this important? Why do we care about studying these properties? And so we'll talk about that in the next videos. All right, I'll see you then.